Hi again, this is Sammy. I'm going to continue proving some identities. So we're going to start off with this one right here. So it's a bit of fractions involved. Now, in this situation, you always look at your trig identity sheet. If you see anything that you could replace here is fine. Otherwise, so basically you look, is it double angle identity? Is it Pythagoras? But none of that is here. So here, the only thing you could do, so we're going to work on this side right here. And the only thing you could do right now is change that cotangent theta to cosine over sine. So you have your identity sheet. Some of you, they just give you your identity sheet. Some of you, you have to memorize them. But anyways, you could just look it up. Cotangent theta is cosine over sine. So we rewrite this as cos theta plus cosine theta over sine theta all over 1 plus sine theta. When we get to this stage, what you need to do now, you need this here, the top, you need to make it under one common denominator. So since this is over 1, then the common denominator for the top is going to be sine theta. And then you multiply that into there, so you get sine theta cos theta, and then this stays the same, the cos theta right there. And then you still have all over 1 plus sine theta. And that's over 1, of course. Now what I'm going to do, if you look at the top here, both terms, you have two terms, both of them have cos theta in them. So definitely take that out as the greatest common factor. So cos theta. And then you end up with brackets sine theta plus 1 all over sine theta right there. And this is your main fraction right here. So fractions is the same as division. So what I'm going to do, I'm going to change it to multiplication and flip the divisor. So you flip this and this becomes 1 over 1 plus sine theta. And therefore, now this and this are the same. So they cancel each other out. And you end up with cos theta over sine theta, which is the same as cotangent theta, which is that. So cotangent theta equals cotangent theta. And this has been proven. Okay. We'll go to the second one. The second one, as you see, it has a double angle identity. So it's a double angle right there. But the first thing you should see in here that both terms have tan theta in them. So you should take that tan theta out as the greatest common factor. And that's the first thing we should do. So tan theta. And then we end up with cos 2 theta plus 1 in brackets. And you're trying to make it equal that. So at this stage here, cos 2 theta right there, you have 3 choices from your identity sheet. So you could change this to cos squared plus sine squared. So you could change it to cos squared theta minus sine squared theta, which definitely you don't want to use this because it's not going to make this any simpler. And then you have 1 minus 2 sine squared theta. And also you don't want to use this, and you'll know why once I tell you, I'll show you which one you should use. You should use the option for cos 2 theta, that's 2 cos squared theta minus 1. Now, if I plug that in for cos 2 theta right here, you'll see, I'm just going to write it right here, tan theta. And cos 2 theta, I'm going to change it to 2 cos squared theta minus 1. And I still have that plus 1 right there. Why I chose this? Because I want that negative 1 and that plus 1 to cancel. Now, what do we have here? We have 2 cos squared theta. Also, the tan theta, I'm going to change it to sine theta over cos theta times, we just have 2 cos squared theta there. And then this cos theta here will cancel with the square in there. And you end up with 2 sine theta cos theta. And guess what that is? That's definitely sine 2 theta, which equals sine 2 theta. And that's what we need to prove. And these are the two proofs. Nice and simple. Just lots of fun, you know, changing things around and getting to a common place. It's always great. All right. Again, thanks as always. Till next time. Bye-bye.